Welcome to another performance related video. We've released our memory package recently and I created lots of overloads for methods which queried the memory data. And here in this video I want to show you in a pet project why that matters. Like the actual memory package needs to give you information like give me the closest memory of this NPC which involves shooting and in the last 15 seconds, or give me the last memory of this NPC in the last 25 seconds which is of type jump or has ID of X, or different conditions basically, or ends before 25 seconds and different conditions. And for those you usually need to either code this stuff once and then use it everywhere, or you need to basically code different overloads. And most people not only code different overloads, but worse, they code it in a way that they go through the array of memories or list of memories multiple times. So we have lots of get closest memory overloads as you see here. And in the underlying containers, let's see. So for example here, there is a get closest memory. Here the function basically only checks initiator, target, and time related information. There are lots of other overloads. For example, this one checks action ID and then time. And I could make like the biggest overload which checks everything and call that for all of them, or worse, I could go through the list once and get all of the items which have the same initiator and then create that list and then go through the list again to basically find all of those which are in a good timing. But that's not good, and I didn't do that, and the memory package is available on the asset store and linked below the video. But let's see how much important that really is. I defined a class called item, and it's not a value type, so it will be all references all over the cache. But still, let me show you how this matters, how much this matters. So we have a count, we have a quality, and I intentionally use different data types because in the real world that will be probably the case, and weight. And then I define multiple functions. Let's say we want to get list items with specific weight, less than something. Here I just create a list of items and then fill some stuff in, 300 of them, and then I test the different benchmark functions. So there is filter the list with weight, which I give it the list and then the weight of 30, and then I will do the same with filter the list with weight and count, but I give max value as count. So basically it uh, doesn't filter anything with count actually, and then with count and quality. And these functions just go through the list and then check weight and count and quality. The other one checks count and quality, the count and weight, and this one only checks weight. And there is another which only checks count because I need that to show you how fast it will be if you first go through the weight list and then through the count list. So we do check the weight one and then weight and count and quality. And last, what we do is that we first get the items with the list below weight below 30, and then we check their counts in another search. So two for loops. So let's see how the numbers are. So as you can see, if we just check weight, it takes only 188 milliseconds to do 100,000 times of this operation. If we check weight and count, it will take 217. And if we check weight, count, and quality, it will be even more. But the version which goes through the list twice, float and int, it will be 325, roughly like 2 times more than the initial version. So it really matters that you actually do not code very generic functions for this stuff that go through a list of things. I'm not saying if it's just one item, but it's almost never just one item. You cannot do that. And it's important to basically do not write clean code which only there's a function which only deals with weight and there's another which only deals with count, because some time in the future you might deal with something which only has weight, and then that function can be quote unquote reused. And then do not convert the list to iList, for example, in C sharp, so it's less abstract, or to IEnumerable like LINQ, because we could do the same thing in LINQ, and that would be horrible. I guess you know that because it allocates a lot as well per